All right, there's a request for me to go over one of these reviews, so I'm going over review number 3. First question is to check to see if either one of these is a solution to this differential equation. The first thing you want to do is look at the differential equation and see which derivatives you need. So we just have a y prime, so we just need the first derivative of each one of these. So on the first one, y prime, if I have e to anything, it remains the same thing, but I have to chain on the derivative of the exponent, which would be a 5. So I would probably look at that as 5e to the 5x. I then am going to take that, plug it in for y prime, minus 5 times y, which is the original, which would be e to the 5x. And I want to see if that equals 0. So I'd have 5e to the 5x minus 5e to the 5x, which does indeed equal 0. So the first one is yes. For the second one, again, I just need the first derivative. So y prime would be 5x to the 4th. And then I just need to take the first derivative, which is 5x to the 4th, minus 5 times the original, which is x to the 5th, and see if that equals 0. That would give me 5x to the 4th minus 5x to the 5th, which clearly does not equal 0, so that would be no. All right, the second question is a slope field. Our differential equation is to simply subtract the x and the y coordinates. So I always want to try to look for a pattern. I like to figure out where that would be 0. That would be 0 if x and y were the same number. So that's going to happen at 0, 0, at 1, 1, 2, 2, 3, 3. All of those are going to be 0, negative 1, negative 1, negative 2, negative 2, and negative 3, negative 3. Then I would probably just start to figure out what's going to happen, on each side of that. If I go to 1, 0, that's going to be 1, but that means along that diagonal. Usually if one pattern happens along a diagonal, that's a good indication that another one will. Not always the case, but 2 minus 1 would also be 1. 3 minus 2 would be 1, and so forth. So as with these down here, if I did the x coordinate minus the y coordinate. So then I'll just go over 1 from that. 2, 0, that would be a slope of 2, right? 3, 1 would be a slope of 2, so I'm going to make those a little bit steeper. And I kind of just can tell that the pattern is going to be, as I get further to this corner down here in the bottom right, these are just going to get steeper as I go down that way. So I'm just going to make these steeper and steeper as I go towards the bottom there. On the other side of this, what would happen if I went up here to 0, negative 1? 0 positive 1. 0 minus 1 would be negative 1, so it's going to give me a slope of negative 1 there. 1 minus 2 would be negative 1, and so forth. So I kind of see that diagonal pattern again up here. Then, 0, 2, that'd be a slope of negative 2, so it's going to be steeper negative. And so it's kind of telling me that it's going to do the same thing that it did down here, but they're going to get more steeply negative the further up into this corner that I go. So I'm going to make these steeper and steeper and steeper negatively as I go up there. Okay, so my slope field is going to look something like that. If you are given this initial condition, essentially think of that as a point. The 0 is the x, the 2 is the y. I'm going to start there at 0, 2, and then I'm going to figure out where the slope field tells me to go. So if I go off to the left, it's very clearly telling me to go up. If I go off to the right, initially it's telling me to go down here. As soon as I come into this diagonal where I have these slopes of 0, this is also going to kind of bottom out here when I'm in line with that diagonal. And then what's going to happen is it's going to go across to where that slope of 1 is at and kind of just follow that line. So that would be my graph that would go through the point 0, 2. All right. The last questions here are to solve separable equations. The first thing you always want to do is, if you have y prime, change that to dy over dx. And then your goal is to get the x's on one side and y's on the other. If you have a situation where you have, in this other fraction over here, the x stuff on top, the y stuff on bottom, you can do cross products, and that will do that for you. So that would give me y dy equals 4x dx. Once you have them separated, you can go ahead and integrate both sides. The antiderivative then of y is 1/2 y squared. The antiderivative of 4x is 2x squared plus c. And then I want to get y by itself, so I'm going to multiply by 2 to get rid of that 1/2. So I would multiply this by 2. That would give me y squared equals 4x squared. And remember, we can just leave c as c, because it doesn't matter if I take a generic constant and multiply it by 2, it's still going to be a generic constant. Then I would take the square root, and I would be sure to put plus or minus in front of this. So plus and minus the square root of 4x squared plus c. That would be my family of solutions to that differential. Next one. We've already got the dy over dx part taken care of. So what I would do as my first step, I can tell I can't do cross products because I don't even have a fraction on the right side. So what I would do is I would multiply the dx over to the other side. So that's going to give me x cubed e to the negative y dx. I've talked to a few people about this. A quick trick that you can use is if you have a term with a negative exponent on one side, you can put it on the other side with a positive exponent. And the reason you can do that is because e to the negative y essentially means that this would go to the bottom and become e to the y, right? I could put an e to the positive y down there, and then I would multiply that over to this side, and that is why it becomes positive over there. So I've got e to the y dy equals x cubed dx. I can now integrate both sides. Antiderivative of e to the y is e to the y. The antiderivative of x cubed is 1/4 x to the 4th plus c. And then the way that we get rid of e is to take the natural log of both sides. So I'm going to do the natural log of the right side as well. And that will simply give me that y equals the natural log of 1/4 x to the 4th plus c. And the last one, I have this y squared in front of this. That's fine. I'm just going to leave it as y squared times dy over dx. I'm changing my y prime there. Equals the sine of x over y. I can't really do cross products. I mean, I guess I can. If you put this y squared on top, then you could do cross products. That makes sense. What looks like I should do to me is that I should multiply the y to get it over here. And when I do that, that's going to give me y cubed times dy. And at the same time, I'm going to go ahead and multiply the dx over to this side. And that's going to equal sine x dx. At that point, I can integrate both sides because I've got my y's and my x's separated. The integral of y cubed is 1/4 y to the 4th, and the integral of sine x is negative cosine x plus c. 4 to get rid of the 1/4 that's out front. That's going to give me that y to the 4th equals negative 4 cosine x plus c. And then I'm going to take the 4th root and to have that y is going to equal the 4th root of negative 4 cosine x plus c. So those three were pretty straightforward. Keep in mind you might have u substitution that comes into play if you get to a point where you're at your integral stage and what you are trying to take the integral of is not something where I just have a bunch of separate terms or just one term there. You do need to use u substitution to evaluate those. On the other reviews, I think I might have a problem or two that require u substitution. So you might want to check those out, but that is review number 3. If you have questions, see me before the quiz, which will be on Thursday and Friday.